Hey guys, Mr. Brading back here to talk to you guys about forces and acceleration and the vocabulary involved here. So pretty much this is the last unit before we begin our challenge, and we're going to be covering forces, acceleration, pressure, and Newton's 3 laws of motion, in addition to all the concepts that we've already covered. So the goal is to have a basic understanding of how force, acceleration, and pressure are related. So there are 7 different success criteria. The last 2 are lab related, and then the first 5 are going to be written or tested at the end of the 2 weeks. Alright, so here's your vocab. You have force, pressure, Newton's 3 laws, and unbalanced force. So force is pretty much just a push or a pull. So if you push on something or pull on something, it's a force. Now another example of this would also be, let's say if you have 2 asteroids in space and they crash into each other, they are putting a force onto each other because they are both pushing on each other, no matter how short of a time the push is. Pressure is pretty much how much force is on a specific area. Okay, an example of this is if you go up to someone and you push them with your hand with maybe a few newtons of force, it might push that person back. But overall, it would do no damage to that area. But if you were to take a needle and push it just as hard, the needle would actually puncture through their skin. The reason why is because there's a very great force on a very small area. Okay? So because there's a great force on the small area, we call that a very high pressure. Alright, now Newton's 3 laws of motion. This is actually a pretty big deal. There's 3 of them. And it's actually really easy to remember these 3 laws of motion and which one is which, because they go in a very logical order. They build on each other. So the very first law, it's very simple. It says that objects are lazy, meaning that if there is absolutely no force, then objects don't accelerate at all. So if they're staying still, they stay still. If they're moving, they stay moving at the same velocity in the same direction. Okay, so again, first law, no force is involved. Now the second law brings in, well, now if there is a force, then this will happen. And that's what brings up the equation force equals mass times acceleration. And this is really easy to understand in the fact that if you have a large mass and you want to accelerate it, it takes a greater force. So in other words, it is easier to push a small car versus a large car. Now let's say acceleration. It is also related to the force. It's directly related to the force. So the greater you push something, or the more force you use, the faster it goes. It just makes sense. I mean, that's common sense, things that we have seen. We're just simply putting an equation to it. So these are all in the equation: force, acceleration, and mass. Now the third law comes along and it says, well, also when we have a force, there has to be an equal and opposite force going the opposite direction. So first law says when there is no force, this is how an object behaves. Second law says, well, when there is a force, this is how it will behave. This is what happens. And the third law says, well, when there is a force, this is what also happens, is that there's an equal and opposite force. Now every once in a while you hear this unbalanced force, okay? Because sometimes on an object, let's say 2 people are pushing on opposite ends, but one person is stronger than the other. Because that one person is stronger than the other, it's an unbalanced force, meaning that there will be acceleration. Now both people are the same strength and they're pushing on opposite ends. The force is balanced, thus it means that the force is 0. Okay, and the example here, when the summative or overall force on an object is not 0. So like I said, when there's two people pushing on opposite ends equally, that means the summative force is 0. But if we have someone pushing with 10 newtons and then another with 20, then we say, okay, well, the summative, or the difference between these two, is 10. So the difference, or summative force, is 10 newtons, and that is an unbalanced force. That's pretty much it for the vocab today. Other than that, I will see you guys next time.